So hello viewers, moving on to the next question in the series of GATE 2026 Electrical Installation from subject Power Electronics. And in this video we will be doing the detailed solution of the question number 47, which is a 1 mark MCQ type from voltage source inverter with power MOSFET switches. Question goes like, consider a single phase voltage source inverter circuit feeding an inductive load. Assume that the power MOSFET switches are ideal. S1 and S2 are switched on during the first 10 microseconds and S3 and S4 are switched on during the next 10 microseconds in a switching cycle. Switches in the same leg are thus switched in a complementary fashion. Neglect the dead time. The waveform of the inductor current IL in the steady state is triangular with a peak value of 5 ampere as shown. This is the inductor current waveform. The inductor current. The RMS value of the current source switch S1 is options given as A 2.88 ampere, B 2.04 ampere, C 3.54 ampere, D 2.50 ampere. Let's move on to solution to the question. तो solution में बहुत ही simple है. Actually क्या है कि S1 क्योंकि first 10 microseconds as it is conducted the first 10 microseconds. So in the first 10 microseconds the current through the switch S1 will be equal to the inductor current. And as it is switched off in the next 10 microseconds, when S3 and S4 are conducting, complementary means S1, S2 and S3, S4. So when S1 is conducting, S2 is conducting and S2 is conducting. S3, S4 are off. And when S3, in the first 10 microseconds, in the next 10 microseconds, S3, S4 are on and S1, S2 are off. So current through the switch S1 is equal to the inductor current during the first 10 microseconds of the 20 microsecond साइकिल. ठीक है, तो इंडक्टर करंट जो स्विच टू द करंट S1 का वेवफॉर्म हम लोग ड्रॉ कर सकते हैं कुछ इस प्रकार, लाइक दिस. somewhat like this. Okay. Switch S1, ISO. Retro switch S1 waveform. Okay. So we want to find the RMS value of the current. This current RMS value of the current switch S1. RMS current to switch S1 will be what? IS1 RMS. For the first 10 microseconds, we can write the equation of this as what basically? T minus 5 in amperes. If T is in microseconds, it's T minus 5. Right. So using the definition of RMS value, we can write square root of 1 by T 0 to T IS1 square dt. तो ये बेसिक डेफिनेशन हो गया. इसमें वैल्यूज पुट करेंगे. 20 माइक्रोसेकंड्स साइकिल होता है, t इक्वल टू 20 माइक्रोसेकंड्स. फॉर द नेक्स्ट 10 to 20 it is 0. So we will integrate from 0 to 10 and IS will be what? T minus 5 IS1 square dt. तो इंटीग्रेशन हम लोग कर सकते हैं परफॉर्म. ओके. 1 by 20 हो जाएगा इधर और इसका T minus 5 इसका इंटीग्रेशन हो जाएगा T minus 5 whole cube 1 3 and the limits will be from 0 to 10. So we put equal to 10 इधर पुट करेंगे तो क्या हो जाएगा 5 और 0 पुट करेंगे तो -5. So it will basically what under root 60 5 cube minus -5 है ना. 5 cube होता है 125 -5 cube होता है -125. तो 125 minus 125 हो जाएगा 250. So this will be what? 250 by 60, 20, 60, 25 by 6. Root 25 is what? 5. And so it's going to be what? Basically 5 by root 6 amperes. If you put this in the virtual calculator, we will be getting, I think, 2.04. Okay. So it is nearly equal to 2.04 amperes. The RMS current of switch S1, as you can see. So I basically explained how the circuit is working, how the switches are conducting the inductor current. In the first 0 to 10 half cycle, 0 to 10 microseconds, S1 is conducting. The next 10 seconds, it is not conducting. So I drew the waveform. From there, calculate the RMS value using the definition. And the solution is clear and comprehensible. That's what I